Hello everyone and welcome to WEkEO for Coastal Interactions workshop. My name is Daria, I'm from Maltese and today we are here to learn how to use various WEkEO platform products in QGIS software. And more specifically, we're going to focus on an exercise about evaluating flood risk in coastal areas based on example of a city of Bayonne. This video is a step-by-step tutorial and there's also additional material which is a document in which this step-by-step procedure are also written. So if you prefer to follow the steps in a written form and not in a video, you also have this possibility. In this video, we're gonna briefly speak first about the context of our study, then we're gonna look at the products we're gonna use, also how to download them and where to find them, and then we move on specifically to the project, QGIS project. So first of all, let's speak about our context. So as we are studying flooding hazards here, we're going to talk a lot today about sea level rise. Extreme sea levels have risen along many European coastlines due to higher mean local sea levels. With sea levels rising over 10 centimeters, most locations will face critical conditions more often. And without improved coastal defenses, projected sea level rise could increase the frequency of extreme high water levels along much of Europe's coastlines by 2050 only, with variations by location and climate scenario. So, from this context, we see clearly that such phenomenon as flooding and flood risks is a very important phenomenon to study. It's very important to estimate the hazards that might come from flooding, especially in the coastal areas, to protect, to estimate, and have a to prognose the possible damage that can be brought onto population. Here you have a little on the slide you have a little diagram with urban populations at risk by 2050. Of course, it's a forecast, and yeah, this is a city is projected to receive at least zero point 0.5 meters, so 50 centimeters of sea level rise by 2050s. Here we see that a lot of coastal areas, a lot of coastal cities are endangered only in like 25 years from now. So to study this, to evaluate the possible risks and to look at our study case, we're gonna, as I said, we're gonna now look at WEkEO platform itself. So this is how WEkEO platform looks like. Let me see, for example. And here, okay, let me do this. This is how it looks like. You can sign in and you can access all the data from this platform. Then you create your own account, you register, and then you can have all the data is all free and available for you. To download the data from WEkEO platform, there is this little article here explaining how to do it. There are two ways to do so, and they both explained here. The link to this article will be given in a document, which the document of a procedure of this tutorial. And you can also in the same document, there's also a little short explanation on how to download data from WEkEO platform. So feel free to use whatever suits better your needs. And today we're gonna look at two products. So first product is a Copernicus digital elevation model in 30 meters. So this model, as it's written here, represents the surface of the Earth, including buildings, infrastructure, and vegetation. So this is going to be our first data we're going to use. And then the next one is Urban Atlas, which is information data about land cover and land use for functional urban areas. And functional urban areas is the area, the urban area, the city area, and the areas that are adjacent. So these are our two data sets we're going to use today. And without further ado, let's get started and go to our QGIS software. So as soon as you have a QGIS, you create a new project, and now we are ready to begin. Before starting specifically with our data, we're first gonna add a layer which gonna represent our background layer. For this, we go to Layer tab here, Add Layer, and we go to Add XYZ layer. Here we have XYZ connections, and if you are new to QGIS, you probably have none. So what you would need to do is to create a new one and fill the name and the URL, which is given in the document of this tutorial, but you also can Google and find more information and more different background layers. For example, we're going to use one specific one explicitly from Google Satellite Hybrid here. I can show you that's how URL looks like, so not very straightforward. But you, of course, can use this one. We provide this information, or you can maybe use our one which suits you better. Here, what we do, we click on Add. We choose it from the list and close. And now we have our background layer, like in Google Maps. How we see it. We're gonna zoom a bit to Bayonne area because that's where we're gonna study it. Up here in South France. Okay, it's here. And now we can start with our exercise. So today we're gonna have two sub exercises, and the first one is gonna be focused on data which is coming from satellite data. So it is represented as raster tiles. And first, what we're gonna do is we're gonna import them. So we go again to click on layer, we add layer, add raster layer. For this, we browse and we go to um, here. We're gonna provide you with data, with all the data, all the inputs, so don't worry about that. And here we have two Copernicus digital elevation model folders in which we have specifically this file. It's a DT2 format file, and this is a raster file. So we can click on it, open, add, and close. And it has been added. Let's zoom out. Ah, yes, okay, it's here. Other possibility of adding a layer in QGIS, especially a raster layer, you can drag and drop it like this. Oh, like this. So now we have two tiles. You see, we can untick them to not to see them or to see them again. And this is our raster tiles with elevation model of coming from Copernicus. So this information kind of not gives us much, but we're gonna work with these tiles further. But first of all, as we have only two of them, so to make it easier to facilitate our future work, we're gonna merge these tiles together. For this, I think, uh, okay, we have such a thing as a processing toolbox here. If you don't have this open here, you go to this little toolbar. In the toolbar, you have this little tool, you click on it, and here we're gonna put merge. And then we have raster miscellaneous merge. We're gonna use this tool to um, merge our layers together. So we go here in the parameters, input layers, of course, we navigate and we choose our two Copernicus tiles. Click on OK. Then we can save it or not save it. It really depends. But let's save it to a file. And let's just create a new one. And here I will call it Copernicus DCM merged. Okay, we click on run and it's running. I hope it's not gonna take too much. Ah, no, okay. Close it. And if we untick our two layers, we're gonna see that now we have exactly the same one, just as one. So now, um, sorry for that. Now, what we're gonna do is we're gonna adjust a bit the representation of our data to see better, to see the model better. For this, we double click on it and we go to symbology. So here now we're gonna play a bit. This part is up to you. You can play as much you want and see with different details. But we're gonna do just for us, we're gonna choose single band pseudo color. We're gonna choose, well, yeah, magma is okay. Let's see, I don't know, let's put 0 to 200. Um, from dark to light, label precision, we can leave it at 4. Mode, let's say continuous. Yeah, let's apply and see how it worked. Ah, it already worked, great. Click on OK, and now we see basically the same layer we had before, just in a bit different presentation. Um, Different colors. You can play as you wish and see um, with like different details, different settings, how it can look like. So as we have it, now we're gonna move on, and the next part is we want to simulate our sea level rise scenarios. And for this, we're gonna use the elevation threshold, like as we're gonna call them. So we're gonna look at 5 different thresholds of sea level. So potential, well, we're gonna look at the 0 meters, like there's no sea level rise, at 2 meters, at 5 meters, at 10 meters, and 30 meters. So +2, +5, +10, +30. For this, we're gonna use a raster calculator tool. We're gonna You can see that actually in Processing Toolbox there are a lot of different tools here, and you can go and explore a lot of features that can be useful. We're gonna go for raster calculator, as I said. If you put raster, okay, it's here, and um, what we're gonna do, raster calculator. Oh, let me move it a bit. Okay, doesn't want to move. Whatever. So here what we're gonna do, we're gonna choose expression, and our expression, this is our merged, right? Yes, okay. First, what we're gonna do is we're gonna, what we need, one what less or equal to 0, right? Like this. Why doesn't it work? Okay. Ah, yeah, well, yeah, because there's this sign, sorry, yeah. Okay, and there should be some reference layer. Let me, oh, reference layer, we can choose one of the tiles. And we will save our result as a file to our new folder, and we're gonna call it as merged, well, 0, right? Why not? Okay, we're gonna run it, close it, and see what is, oh, oopsie doopsie, something went wrong. Let me have a look at it. And I am back. Sorry for this. Yeah, the mistake was is because when I went to raster calculator and I put reference layer, I clicked on the wrong one. I clicked on one of the tiles and not on the merged one. And we of course need the merged one. So after we ran our procedure, we have now this raster layer in which we can see with water, kinda, um, our values that are the ground is black and the water, whatever our things are white. So like this, we have our model for zero sea level threshold. So now what we're gonna do the same thing, but um, for our four thresholds, as I said. And I don't think I'm gonna show you it all step by step, but we'll just, you go back to Raster calculator, you put what is supposed to be like less than 5, for example, I think. Let's see at least. Mhm. And we save it to file also. Oh, we run, we close, and we see. Oh, yeah, another mistake has been done. We always need to choose, yeah, I think I less than 5 merged. Okay, save to temporary file, save to file. Oh, yep. Yes, okay. Now we have, you see that with the 5 meters sea level rise, we see that the water is kind of like spreading more comparing to the zero one. I'm going to repeat the same for 2 meters, 10 meters, and 30 meters, and I'm going to come back to you. Okay, so I'm back. I already done it. So here we see the threshold of 0 meters. Now it's 2 meters, now it's 5, now it's 10, and now it's 30. Well, quite, it went out of all possibilities here. So here we can clearly notice the impact of rising sea level, which brings upon the coastal zone and even spreads deeper inland. So now what we want to do is to have this information. This information is in raster information, so it's pixels, and we want to have it as a vector layer, so like polygons. So for that, we're gonna polygonize our raster layers, all of them. And let me start with this one. And for this, we go to raster tab. We go to conversion, polygonize. So here we choose our layer. Um, the field to create, we will put flooded, and we will save it to a file. How are we gonna call it? Well, let's call it flooded area 0 meters. Oopsie. Okay, we run. Okay, and we close. So this is basically our same layer, just now it is a polygon. You can right click on it, click on open attribute table, and you see that it's actually consisting of several, like a lot of little polygons, exactly like 1200. And yeah, because there are some small features here, for example. So the next step to do is to do the same for our layers. I'm gonna come back to you with that, so not to take a time. And I'm back with results like this. You can see, oh, but as you see, we can now it is polygonized the whole picture, the whole tile, and we need only the water part. For this, we're gonna filter it. And for this, we're gonna right click on each of our layers and go to filter. And we're gonna filter like flooded equal to 1. We can test it. Oopsie, oh, okay. We're gonna untick our layers, and now we tuck. And now we see the only water parts are represented. So only the flooded parts, let's say, are represented. So now we're gonna repeat the same thing for other layers. Right click, filter, flooded equal 1. Okay. up, and we're gonna do the same for the others. And again, I'm gonna pause the video to not to take your time. And I am finished with that. Now you can see our kind of evolution of our threshold. So, as I said, for our eyes, it doesn't look much different. Like for us, it looks like one big polygon, but if you really zoom in and we see that it actually consists of many, many small polygons. And what we want to do is we want to um, like merge these different entities into a single one. And for this, we're going to use a dissolve um, function, but we're gonna only look on three of our layers. We saw how it can we saw the evolution of our thresholds from 0 meters to 30, but we're gonna focus only 2 meters, 5, and 10. So on these particular three ones what are ticked. But before we what eventually want to do, we want to actually merge them all in the same file. I'll explain it later, but first let's do, as I said, let's dissolve our polygons. For this in the raster toolbox, we put dissolve here, and let's choose one by one. So we said we're gonna look at the folder, okay? What else do we need? This one? No, we can save it. Save to file. Well, we have a little area like this. Let's put a little up like this at the end. An important thing here is we go to this little tool here, and in invalid feature filtering, we're gonna skip. Yes, we're gonna use a skip. This one is just to make sure that all the features gonna be processed nicely. After that, we run. Yeah, it will give us some. We're gonna close it, and well, let me oop, flooded area up. Uh-huh. Well, it actually didn't process it as we wanted, unfortunately. So yeah, we will. No, it didn't work this time. Let me look at this. Probably is because of. Yeah, okay, let me look at it. So I am back with you. I found the error. So I fixed it really quickly, relaunched it, and now it's all good. So we use the same tool, the dissolve tool. And basically, if you look our layers before dissolving and after dissolving, up, and we will see that if we go and open attribute table, we see that now it's one entity um, instead of several. So now the next step is, as I said, we want to have all our these new vector layers, the dissolved one. We wanted to merge them in one, and for this we're gonna use another tool which is called merge again, but now it's not raster layers but vector layers. So for this we will put merge again, but now we search merge vector layers, this one, and in inputs layers we put our dissolved ones. Yeah, also the ones for our three. Okay, okay, good. Um, and let's save it to file as flooded area merged. Okay, let's hope no errors here. Okay, and now it's all together. I hope it is as it's supposed to be. And let me just check. Okay, yeah, it seems like it's good. So now we can see, we like right click on it in open attribute table, we see that we have one layer one polygon layer, one vector layer consisting of three vector layers in which each one represents our simulated scenario of sea level rise of 2 meters, 5 meters, and 10 meters accordingly. And for this, our first exercise, which was about to look at the sea level rise, is done. And the second part of this tutorial and the second exercise is to see how it is impacting the population. So for that, we will look at another at the second product of this from WEkEO platform, which we already looked at. We saw its information, and it's an urban atlas. So it provides us land cover and land use data. So first, um, we're gonna import it, and we go to your layer, or like let me just to the data. We go to data. We have this folder. We go to data, and we can drag and drop. And here it's actually this one layer, as it also consists of three sublayers. You can choose one of them, like two of them, or all three of them. We're gonna import all three of them. Just some error, okay. Yep. And okay, so here we have three new layers, and we see here, what's it called? Okay, it's gonna take some time to load. So here it's called urban core, so it's only the city itself. Then we have boundary, which is one polygon. It consists, I think, of one only. Yeah, you see one big one, which shows the whole um, urban area with adjacent uh, land. And then we have this type of, which gonna take some time to load. So yeah, consists of small little polygons all over the place, which represent different type um, of like land use. You can see it here. It's very not representative, but we can make it more easy to understand what's happening. We go to this layer by double clicking on it to go to symbology, and this we need to actually load a style, because here we go to style, load style, and we load from file, and in this folder with urban atlas there's already a legend. So the provider of the data thought about it before and had additional information in this file. We will load style, we click on apply, OK, and yes, it will can take some time to load because it's a lot of data. But now you see that actually our polygons are all colored in different colors. So each color represents a specific zone, like pastures or port areas or isolated structures and so on. And urban area, you see it's more dense, highlighted in red colors. As we're gonna focus only on urban core, so only on populated areas, we're gonna clip our vector layers. So let me untick it so it doesn't take our memory, and let's clip it. So we search for clip, vector, overlay clip. Input layer is our big one, yes. Overlay layer is only urban core, and we will save it as um, urban core, urban atlas. Okay, we run it. Shouldn't take much time, I hope. Okay. Okay, and now we have exactly the same kind of layer, you see, with also with small polygons, but um, only for our urban area. And we want to see the same representation in terms of color, so we right click on our previous layer, which already had this style, and we go to style, copy style, all style categories, and we style, paste style, all style categories, this one up. And now we see our this pretty image of our small urban area core, also colored in these nice fancy colors depending um, on the land use. So if we click on our open attribute table here, you can see a lot of data, right? And here we have one column which is called pop to 2018, so it's population for 2018, and you see how for each small polygon there's a population for it. We will use this column later, and our goal for this exercise is to see how many people can be potentially affected by the sea level rise we simulated, right? So we simulated for plus 2 meters, plus 5, and plus 10 meters. So let's see how to estimate the population impacted uh, by these simulations. But we need to do some more preparations before we move to this part. And we need another layer for that. We need our other layer. Yeah, right. We want to have this layer performed we had as a result of our first exercise. We want this one to be clipped to the big boundary layer of this one. So for this, we do exactly the same thing. We go to clip, we put flooded area merged. As the overlay layer, it's a boundary, and we save it as um, flooded area. Well, we have merged already, so yeah, well, it's clipped, so let's clip it. Let's clip it. And here it is. Great. So now let's see what parts of urban core is prognosed to be flooded by our simulation and how significant the impact could be. For this, we go to our processing toolbox and we search for join, and we go to join attributes by location summary, this one. This one tool we're gonna use now. So now in the join attributes, we're gonna choose our input layer, and input layer, let me just verify, yeah, it's urban core, this one that we prepared, and for join layer is the one also that we prepared, the clipped one. As geometric predicate, we choose intersects, then fields to summarize, it's only flooded. Summarize the calculate, we will choose only count, okay. And well, let's save it now. Well, urban core flooded. Flooded. Okay. We run and close when it's finished. Ah, right. Well, yeah, exactly. This procedure takes some time, like really some time. So I will pause the video so it doesn't take time on this video. So now it's finally finished. It took some time. It's getting dark also in my office, so I turned on some light. Um, so now we have our new layer, which is looking exactly the same as the previous one, basically. The only thing is, if we right click on it and open attribute table, we will see that we have one new um, um, sorry, column. Um, this called flooded which means flooded count actually, because it's cropped, which means that here in each polygon there's 3, 2, or 1. It means that if only um, the 3 means that this polygon, this small polygon of this urban area, let me see, show you. It means that this one of these small polygons, if it has 3, it means that it intersects with all 3 layers, with all 3 features of our clipped merged flooded area. So it means that it touches all it is impacted by all three simulated scenarios, plus 2 meters, plus 5, plus 10. If it's 2, but it's only plus 5 and plus 10, and if it's only 1, it's only plus 10. So that's it. Um, Now we're gonna see a bit how to adjust this data, because how to adjust the representation, because well, now it's not very um, understandable, let's say. So for this, we are gonna work with our new layer. We double click on it, and we have here like single symbol, but now we're gonna do categorized. The value, we will choose our new flooded co here, and symbol, let's choose, well, just mm, like this. And color, let's say blue. Let's invert it and classify. Yes, okay, we classified it. Uh, okay, this class, how do we remove it? Yeah, okay. We will delete this one. Okay. Okay, we click on apply. Okay, and now let me untick this one. Okay, we go back to our layer. Let's adjust the legend. For the legend, we will change because 1, 2, 3 doesn't really say things for us. Well, we will change it accordingly. So 3, as I said, it should be plus 2 meters. 2 is plus 5 meters. I hope I'm not making it wrong. Let's see. Yes, exactly. So now you can see that, for example, here we see now only the um, how to say, yeah, only the zones, only the polygons um, of the urban area which are affected by our simulated sea level rise of plus 2 meters. If we put plus 5, we see also more polygons, more like inland, more in the city, let's say, are added, and also plus 10. And the last thing to do is to filter our layer additionally. Well, we already know how to do it. And we will filter it by population. And let's put what the population should be more than 0. So we are only interested in, yeah, areas that are populated, because, well, we want to see, um, we want to know for population impact, not, yeah, not impact on whatever area. So here it is. Now we see only specific areas are being highlighted. And next one step, it's a statistic computation. So here we want to see the amount of population that might be impacted by the scenarios we simulated. Um, and we also want to know the number of those people, of course. First, we have our layer. Let's duplicate it. So we're gonna duplicate it. It's just right click, duplicate. We put it on top. And now we don't need this layer. Let's look at this one. And we're gonna change the symbology now. So to see a bit different things, to be honest. So we still have categorized. No, wait, no, it's graduated now. It's graduated. And now we don't want to look at the parts that are really flooded, but we want to see the population. So let's choose now different color. Let's put red. Color ramp, oopsie, nope, not like this, but reds, and well, we inverted from white to red. Precision can be 0, it's okay. here in the mode, we chose natural breaks jinx and we put 10 classes. Oh, 11 too much. Let's stay in 10, okay. And now we put on classify, apply, and okay. Okay, so now we see that. And now this is our urban area, urban core area, which is color coded according to the population. So here, for example, you can see that the most lightest parts of it have a very few people as population there, and very dense ones are more and more red. And again, same filter. Let's apply. Make sure it is more than 0. Yep. Okay. It's already applied. Great. And now, if we open our attribute table, um, let me see. What do we want to see? Yeah. And here in our flooded count column, we see that there are some sorry for that. There is some lines, some polygons that has null as its value. And this is due to the fact that, for instance, this for this exact for this polygon, um, it is the urban area's population is bigger than 0, regardless of the potential flooding status. And we, of course, can filter it a bit more. For example, let me choose. We also can click here on filter. For example, if we put this one, still population 0, and we put end, and we put flooded co equal to 3, we see only this as a result. So these are going to be only only parts that are impacted by +2 meters sea level rise. We can also see, oops, can test it with 2 to see the difference. Okay, and 1. That's it. So yeah, and let me just look what we wanted to see more. Right. We now want to uh, do some statistics, as I said, statistical computation, or more specifically, we want to calculate the overall endangered population by the flooding type. Before we do that, we first need to remove this filter for, we leave it only for population. And then we go to our processing toolbox and we search for statistics. Statistics. Is it already appearing? What I need? Statistics by category. Statistics by. Okay, this one. Here we choose our flooded copy and put vector. Field to calculate is population, and field with categories is flooded. This one. Oh. Um, okay, let's run and close. Great. So now we have statistics. This new layer is basically not a visible layer. It's just data. So for us to see what's actually in there, we right click on it and we go to open attribute table. And here we see our flooded our status, like our one of our three scenarios, and then many statistics. We are only interested in the sum, so it's this one. And if you want, you can hide the others one, like right click, hide column, like this, as you wish. And yeah, I can maybe do that. And we can also, what we can do is add another We can add another column. Let me show you. So first we go to this editing mode, we toggle it, and then we click on a new field. I think it's this one, yellow, right? Yep. The name, we're gonna call it sea level rise. Um, text, length 10 is okay. Okay, and just just a second, I'll just clean a bit this table and come back to you. Okay, now it's clean, good. What I'm gonna do now is I just in this new column what I just created, it's a sea level rise, right? We put our values to like understand it more. It's plus 2 meters, plus 5 meters, plus 10 meters. Perfect. And now we click on the edit mode again, we save it, and now we have a new clean little table. So in here we see basically on we see like the amount of people, number of people affected explicitly by each scenario as we simulated 2, 5, and 10 meters of a simulated scenario. And on that, the second part of this tutorial is also finished, the second exercise, and the tutorial itself also done. Um, Here today with you, we looked at how to use QGIS software to handle and visualize WEkEO products for coastal interactions. Today we displayed and merged raster tiles, right? We vectorized them in order to conditionally filter them. We compared them to see their evolutions. Um, what did we do? We vectorized those layers, right? We used filtering function a lot. We looked how to um, change the symbology of our layers to make it more representative. We also used statistics computation for specific layers and yeah, to see different numbers and also use raster calculator. So we've seen plenty of features of QGIS, and as products we saw Urban Atlas, which has a land data of like data of land use, and also the digital elevation model from a satellite. That's basically it. I hope you enjoyed it. I hope you learned something new from this tutorial. I hope it was clear. Um, as I already said, yeah, don't hesitate to check the document, like the written version of this tutorial if you prefer to see a step-by-step written. And yeah, don't forget that this um, tutorial can be, it's applicable to other topics, it also can be applicable to the same flooding estimation, but in different area with different data. Feel free to use different data. Feel free to go to different zone and study, make your own study case. Also, don't forget that those features we looked at today, of course, you can use it with different data, not only for flooding, but with different other scenarios, other phenomena. So that's it. Again, I hope you enjoyed it. I hope you learned something new, and have a nice have a nice one. I wish you all the best and bye.